Okay, let's dig into these sources. Because what really struck me is this completely new framework for intelligence.
Mm-hmm.
It's not about one single thing. It's more like a progression, right? 5 tiers, sensory hierarchical, moving from the purely physical up to abstract thought.
Exactly. And if you picture those 5 levels, you've got touch at the bottom, then chemoreception, like smell and taste,
Right.
then visual, auditory, and right at the top, textual or symbolic thought.
Okay.
The really fascinating thing, the symmetry here, is how life and AI took completely opposite paths up and down this hierarchy. It's like a pendulum swing.
A pendulum swing. I like that. So life started at the bottom, climbing up. Let's start there then. The foundation. Touch. Reception.
Yeah, and this is so fundamental. Touch is, the ultimate concrete intelligence. It's direct physical contact, least abstract.
And the oldest, right?
By far the oldest. The sources highlight that the basic molecular tools for sensing touch, they go back over 1.5 billion years. That's before complex nerves, even before multicellular life.
Wow, 1.5 billion.
Yeah.
That's hard to grasp.
It really is. It's intelligence built right into the basic machinery of life itself.
So life starts there, literally feeling its way around, and then climbs this ladder of abstraction, away from direct contact. Was the next big leap. Vision.
Vision was huge, absolutely revolutionary. We're talking image-forming eyes maybe 541 million years ago.
And that sparked the Cambrian explosion.
It's seen as a major catalyst, yeah. Suddenly you don't need to bump into something to know it's there. Game changer.
Okay. And hearing. Where does that fit in?
Hearing and air came quite a bit later, maybe 370 million years ago, and it demanded something new again, processing sound over time, sequentially. That's a step towards language, really.
Which brings us to the top. Text. Symbolic language, that's us, Homo sapiens, and pretty recently in the grand scheme.
Very recent, maybe 50,000 to 100,000 years ago.
But this whole climb from touch to text, it explains something crucial about how we think, doesn't it? This idea of an abstraction gradient.
Oh, absolutely. Think about this. Your senses, all combined, are pulling in something like 1 billion bits of data every single second. It's a fire hose.
Billion bits, okay.
But your conscious awareness, that voice in your head, it's processing maybe 10 bits per second.
10. That's an incredible reduction.
100 million-fold compression. That hierarchy is the evolutionary architecture that filters all that raw data down to what's essential for, thinking and surviving.
Right. Makes sense. Okay, so that's life's ascent. Now flip it. AI's path starts right at the top.
Exactly the opposite. AI was basically born out of math and logic. Think 1956, Dartmouth Conference, pure symbols, abstract manipulation.
Text.
Text was the natural starting point. Why? Because it's already broken down, it's symbolic, it's relatively neat compared to sensory data.
Easier for computers to handle initially, which explains why large language models are so advanced now.
Precisely. They're masters of that abstract symbolic level. But crucially, it's often ungrounded in physical reality.
Okay, so AI starts abstract and then has to descend into the messier stuff.
That's the journey, the difficult descent into analog data. First big step down was auditory intelligence.
Speech recognition, like Siri or Alexa.
Exactly. Those really started working well, becoming viable in the 2010s, thanks mainly to deep learning handling that sequential sound data.
Right. And then vision, computer vision.
That came next, but it's significantly harder computationally. The big moment there was probably 2012 AlexNet.
Ah, yes, the ImageNet competition.
That showed deep learning could really crack visual problems. But understanding images, context, depth, it's just inherently more complex than audio streams.
So AI is still working its way down. Where does that leave us now? What's the final frontier for AI's descent?
It brings us right back to the beginning of life's journey. Touch, embodiment, robotics.
Getting AI into the physical world.
That's the grand challenge. Making robots that can handle objects with dexterity, using tactile feedback, navigating the real, unstructured world safely. Think about trying to get an AI to handle an egg without breaking it.
That requires understanding weight, texture, fragility, things you learn by doing, by touching.
Exactly. It's processing high-dimensional, messy, physical data, the opposite of clean text.
So the symmetry is perfect. Biology climbs up from concrete experience empiricism to build abstract models. And AI descends from abstract models, rationalism, trying to connect back down to that physical experience.
That's the core insight, the pendulum swing.
And the implication for us, thinking about artificial general intelligence, AGI, It seems clear.
Yeah, it's just that just making LLMs bigger and bigger, staying purely in the realm of text, that might not be enough.
That's not the whole picture.
Right. True general intelligence, this model suggests, needs AI to complete that descent. It needs to ground its abstract knowledge in physical, embodied interaction with the world, just like we did.
Which leaves us with a really interesting final thought for you, the listener.
If you have an AI, maybe an LLM, that understands the word apple because it's seen it millions of times in text next to words like red, round, fruit, tree.
Okay, statistical correlations.
Right. And then you have a human who understands apple from seeing it, yes, but also from feeling its weight in their hand, the smoothness of the skin, the crispness when they bite into it, that whole sensory experience.
So what does the AI need to do? What interaction, what experience does it need to have to bridge that gap, to get from the text-based shadow to the actual grounded reality of the apple?
That seems to be the key question on the path towards truly general AI, something to chew on.